As the space shuttle orbits the Earth, it carries out experiments. In 1996, scientists hoped to produce electricity on a grand scale by using a simple physics principle. A wire 20 kilometers long was strung out in space and dragged through the Earth's magnetic field. The idea was to generate up to 5,000 volts, but unfortunately the wire snapped. 150 years ago, Faraday discovered that moving a piece of wire through a magnetic field produced a voltage. If the wire is stationary, nothing happens. Move the wire from one pole to the other, and again nothing happens. Only when the wire moves up and down is a voltage produced. It's all to do with cutting lines of force. The wire needs to cut through the field lines before a voltage is induced. Following a line of the magnetic field has no effect. The results are the same if the magnet moves instead of the wire. A changing magnetic field induces a voltage, and an electric current flows. This is known as electromagnetic induction, and is the main method used for generating electricity. This generator produces electricity by rotating a coil of wire inside a magnet. It turns mechanical energy into electrical energy. Here, the mechanical energy is provided by the human body. Power stations generate electricity in a similar way. Huge turbines are rotated. These are often powered by steam. Other generators use wind. The electric current produced by a power station varies in direction. This simple piece of apparatus shows how. Here, a magnet rotates around a wire. As the magnet moves around, force lines are broken and the magnetic field changes. In this position, most lines of force are being broken. The induced current is at its highest. As the magnet is rotated, the field changes direction and the current also reverses. The current oscillates, first one way, then the other. It's called alternating current, or AC. Once a power station has generated electricity, it needs to transmit it across country to people's homes. Electricity flows along miles of overhead and underground cabling. But when an electric current flows through any wire, it heats up. This steel rod completes a circuit. As the current is increased, the rod begins to glow. Eventually it becomes white hot and so soft it can even be tied in a knot. Transmitting a high current would be very inefficient. Most of the electrical energy would be lost as heat. So how do power stations prevent large-scale heat loss when sending electricity to our homes?